So here we go. Just like before, page 1 is starting with this big equation that we need to ultimately sketch. Alright, so how shall I begin? By factoring? So what do you think about the top? We can take out a 2. And when I take that 2 out, I notice then I have the difference of squares. Some of you are trying to do too much in one step. So let's write it down. Take that 2 out, and then you've got the difference of squares. Keep the 2. All right, what about the bottom? Minus 3 minus 4. Jose? What do you notice now? We are going to have a hole. And ultimately then, what we are going to graph is this. This is all that's left after I factor and cancel. So where is my hole going to be? Oops, I gave it away. My hole is not going to be at negative 3. My hole is going to be at positive 3. And how do I get my y? Plug it in right here. So 3 plus 3 is 6 times 2 is 12. And 3 minus 4 is negative 1. So that's not going to fit on my graph, but it's going to be way down here somewhere. 3, negative 12. Okay? Now, look at your list there. What are some other things we need to put into the picture? The intercepts. Where do the intercepts come from? If we let x be 0, go to your problem and let x be 0, what do we get? If we put in 0 for x, we get 6 over negative 4, which is negative 3 halves if I reduce it, or negative 1 1/2. So 0, negative 3 halves. That is my y-intercept. How do I find a y-intercept? I let x be 0. Right? It's real easy every time. That's y-intercept. How do I get my x-intercept? I look at the numerator. And what's going to make that 0 is going to be negative 3. So there are my intercepts. So there's my hole, here are my intercepts. Now I need some asymptotes. What does that denominator tell me? There's a vertical asymptote at x equals 4. Now, let's talk about that for a quick second, because some of you are getting the letters mixed up. First of all, you look at this and you say, I'm going to have a vertical asymptote at 4. You should be able to tell that from the problem. When you come over here and draw a vertical asymptote through 4, which axis do you cross? X. That's how you know your equation is x equals. Whatever axis you're crossing, that's the letter that's equal. Okay? Now what about my horizontal asymptote?
It's going to be 2.
It's going to be horizontal at 2 Can you see why that's gonna be y equals 2, guys? Look where you cross right there. Y equals 2. That's your horizontal asymptote. Now, once you get all that stuff figured out, all those blanks filled in, then you gotta figure out what your picture looks like. Well, I think it's pretty obvious, I hope it's obvious to you, that it looks like this. It's approaching its asymptotes. So it's following this one out this way and following this one down here. There's a whole other piece to the picture. Where's the other piece of the picture?
In the corner.
Up here, top right, yep, right here, like this. All right, page 1, done. All good? There's a lot of points on that page. Okay. All right, what's on the next page? Looks like the next page we have some inequalities. X squared less than 4x. All right, what do you think? Move that 4x to the other side. Because every time I see a symbol like that, I know that one side has to be a 0. Agreed? Okay, so now I'm here. I'm going to draw a number line, and there's going to be dots on this number line, 2 of them, because that's x squared. How do I figure out where to put the dots?
You take the X out.
I factor, exactly, and this one's a GCF. There are lots of ways to factor. If you have a GCF, take it out. Just like we took the 2 out in our last problem, here we're going to take out an X. So where are the 2 dots then? 0 and 4. Will they be open or closed dots?
Open.
Open. So now I just gotta figure out where to shade. And how do I do that? Pick a number.
1.
1. 1 is a fine number, 1 is in here. So 1 would give me 1 times -3. Is 1 times -3 less than 0?
Yes.
Oh, good, that means I shade here. And if I shade there, then I'm not gonna be shading out here.
No.
So,
0 to 4.
0 to 4, that's it, that's the whole answer. That is the answer to the question. Everybody good? All right, what about this one? It's gonna start the same way, so are you okay if I just minus the 3 right now? I'm gonna subtract that 3 to the other side, because when I see that symbol, I gotta have a 0. So I'm gonna subtract. Okay, now what?
Make the comment up my there.
Get a common denominator, because anytime I have fractions, I want to get a common denominator. So this denominator, that one's fine. This one needs an x minus 2.
Don't cancel out. They don't cancel out.
They don't cancel out, because in an inequality, I'm going to get 2 dots again, one from the top and one from the bottom, so I can't lose the bottom. If that were an equals, I would, but it's not. So, I'm going to keep my bottom, 1, just one of them, just x minus 2, that's my bottom. And then on top, I'm going to have x plus 4. Be so careful here. Minus 3x plus 6. Guys, this number right here messed up probably a third of the class on the quiz. You've got to distribute the negative 3, in this case, times the negative 2. All right, so cleaning up the top, it looks like I have negative 2x plus 10. Okay? The numerator is going to give me a dot, and the denominator is going to give me a dot, and I know my denominator dot is going to be at 2. This one, that kind of stuff always messes me up. So I am going to over to the side, just set it equal to 0 like I did back in the old days when I was little. Set them equal to 0 and solve them, and I got 5. So my dots are at 2 and 5.
5 is closed.
5 is closed, very good, thank you. Because of that, right? And some of you might think, well, wait, they're all supposed to be closed. Well, not if they're a denominator. So that's why that one's open, perfect. What happens now? Pick a number. 0, I like 0. 0's a good choice. 0's out here. 0's easy. 0 would give me 10 over negative 2, which is negative 5. Is negative 5 bigger than 0?
No.
No. So that means I'm not shading here, but I am shading here and not there. So my whole answer is 2 to 5 with a parentheses on the 2 and a bracket on the 5. There's a lot involved in that problem. Everybody keep up with all that? Quigley? All right. Now I have another inequality. Good news and bad news. The good news is that it's factored. So you don't have to mess with that. You go straight to your number line and put a negative 3 and a 3. Would everybody agree with that? Because it's already factored. Those dots would be colored in. What's the bad news?
Need one more number.
Because of the squared, you're gonna have to pick a number here, and here, and here, right? So here we go. Here we go. What number shall we pick? Negative 4. All right, so if we're starting with negative 4, doesn't matter where to start. Pick a number. So negative 4 plus 3 is negative 1. Negative 4 minus 3 is negative 7, but it's squared, so it's 49. Is negative 1 times 49 bigger than 0?
No.
Nope, not shading here. All right, pick a number here. 1. 1 plus 3 is 4. 1 minus 3 is negative 2, but squared is 4. Is 4 times 4 bigger than 0?
Yes.
Okay. One more number. 4. 4 plus 3 is 7. 4 minus 3 is 1, squared is 1. Is 7 times 1 bigger than 0?
Yes.
take a look at your number line very carefully now. Let's use our heads. Your answer is -3 to infinity. Because isn't all that colored in? Once you get started, it just keeps going. So -3 to infinity.
So if you end up putting the, or, is it just wrong?
No, it's -8.
Okay.
Because you didn't put the best answer, but it would be still right, assuming I'm single. Okay? Alright, what about this next one? There's one more inequality. What about this? What do I need to do with this big equation, or inequality? What do I need to do? I heard somebody say quadratic formula. Alright, see these gray hairs? I just got about 15 more. Because when do I use the quadratic formula? In a quadratic equation. Is this a quadratic equation? Now, if this were here, yes. But it is there. So, no quadratic formula. What do I need to do first? Get it set equal to 0. Boys and girls, you have got to have a 0 if it's an inequality. So I added my x and subtracted my 6. Everybody okay with that? Now what? PRRs and synthetic division? Now, could there be a problem like this that grouped?
Yeah.
And if it does, and you want to do that, go ahead. This one does not group. I hope you can see that. It wouldn't group. So my PRRs are factors of 6 over factors of 1. So what do we want to try?
2.
2? You guys always want to try 2, and as long as it's an option, that's fine. Uh-oh. Unless I made a mistake here. I'm not liking the way that looks.
We can go 1.
So, those of you that say 2 always works, change your mind. It doesn't always work, right?
I just picked, it's just more neutral with
It's
everything.
more neutral? Alright, so
Yeah.
what, Izzy, you said 1?
Yeah.
Okay. That looks like a winner. Now, I've seen this on homework. I've seen it on your last test. You guys forget that the number that worked is a dot
Possible.
on your answer, in your answer. So here's my number line, and I'm just gonna put 1 right there. I don't know where it is, because I don't know what else I'm gonna get. But 1 is a dot on your number line. Whatever number worked is gonna be a dot. Okay? Now where are the other dots coming from?
3 plus
They're
6.
coming from
2. I mean, -2.
x squared plus 5x plus 6.
Plus 2 plus 3.
Somebody said plus 2 plus 3. I love it. If I FOIL it, I get 5 in the middle, which is what I wanted. So what does that tell me about the other 2 dots on the number line? There's one at -2 and -3. Is that okay with everybody? Where's the first dot come from? Your division. Do you change the sign? No. That is the dot. Open or close? Open. Now I need to shade. I need you to be careful when you shade though. How many factors should you have? You got 2 of them right here. But you should have a third factor. And what will that third factor be? X minus 1. All right, what number do you want to pick? 0? 0 sounds like a good idea. 0 gives me 2 times 3 times negative 1. If I put in 0, is negative 6 less than 0? That means I will shade where the 0 is. Okay? And if I shade there, then I also shade here. So my answer in the answer blank, negative infinity to negative 3, or negative 2. Everybody okay? All right, we just did 4 inequalities. The next problem is an equation. It has an equal sign. That means, for problem E, I am not going to have a picture, I'm not going to have a number line. I'm not going to have an answer that looks like this. I'm going to have an answer that looks like this.
X equals.
So take a look at the problem. It's full of fractions. We're going to have to make all the denominators the same. Now listen to me, you guys.
You have to make it 8x.
He says you gotta make it 8x. And you actually don't have to make it 8x. You have to make it match. So could I make them 32x?
Yeah.
Could I make them 16x? Yeah. So 8 would be the smallest that I could make it. But there are zillions of common denominators. I do not want you fretting about that. Just get a common denominator, and one way to do it is just multiply these 3 together. 32x would be a common denominator. All right, I'm going to use 8 because that's the first one suggested. 8x, gotta have the x, so it's 8x. So this one gets times by 8, this one by 2x, and this one by x. Good? All right. Now, because it's an equation, what am I allowed to do? Drop the denominators. So 16 plus 6x equals 9x. The reason I have to keep the denominator in an inequality problem is because the denominator actually provides a dot. I'm not on the number line here, so I don't need that denominator. So 16 equals 3x, and it looks like x is 16/3. There is zero reason to mess with 16/3. Just leave it alone. Just leave it.
Well, what if you were offered that 5.3 over?
That's okay, but why would you do that?
It's what the calculator gave me.
You don't need a calculator. Fractions are fine. All right, problem F. Too big for me to put over here, so I'm gonna come back over here. Problem F. Here we go. What am I gonna do? Okay, what am I going to do with this problem? What am I factoring?
The middle.
The denominator right here?
It's here.
Alright, so what does that factor into? This guy right here is factoring. What does he factor into?
X plus 3.
X plus 3, x plus 5?
Yes.
And that's really not a coincidence, Rick. Right now what?
So on problem like this, will there ever be a point?
There can be.
Okay.
So you're better off doing what you always do. This is a good place to start. Just double check it and make sure it's right. Okay? Alright, what do I do now?
College denominator.
I'd say factor at the top.
No. First of all, the top doesn't factor.
Okay.
And second of all, I wanna collect like terms up there, so I'm not gonna factor that, I'm gonna leave it B. But I am gonna multiply this one by x plus 3. That one by nothing, and this one by x plus 5. Now, are all my denominators the same? Yes, so I can ignore them. So I've got 2x, x plus 3, minus x squared minus x minus 10 equals 3x plus 5. Now, guys, I know there's no parentheses up here. But see that minus right there? What is that minus telling me? To subtract the whole shebang, right? I'm subtracting this whole thing. So that negative is going to have to be distributed all across there. Because I am minusing each piece of that. That is gonna trip you up if you're not really into it. Really locked in. You're gonna fall for that if you're not. Alright, are you with me here? That's a mess. Are you good? Alright, so now let's clean it up. So these two are gonna make x squared. These two are gonna make 7x plus 10 equals 3x plus 15. Okay, now what?
You got factor 10.
Great, 3x plus 15 over.
What do I need to do first?
Yeah, subtract.
Gotta get my 0, right? So I'm gonna minus the 3x and minus the 15. So I'll have x squared plus 4x minus 5.
Yep.
No, I'm gonna factor that. By the way, today's Noah's birthday.
Happy birthday.
See the balloon?
We'll check.
Okay.
You said
The balloons are circular.
Yeah, bro. Well, thank you.
You like coconut, Noah?
I do love coconut. Appreciate it. It's my favorite.
Okay. Does this by chance factor? If it doesn't, could we now use the quadratic formula? Because it's a quadratic. But it does factor how? Plus 5 minus 1. Right? So x equals
-5.
-5 and
One.
+1. My little antenna are on high alert because look at my denominator right here. Can x be -5? So the only answer to the problem is
One.
1. These are the problems that have extraneous roots. Sometimes. The one we did yesterday did not. What does your test look like? That's okay. So notice up there at the top, it says, be sure to label your answer. For the word problems, you have to label it. And if you don't, I'm gonna take points off, and how stupid is that, right, to miss points? Because you didn't do the directions, follow the directions. All right, Jane can build a shelter in 4 hours. Maurice can do it in 6 hours. How long does it take them to build it together? So, what's our format?
One
1
over.
over alone plus 1 over alone equals 1 over together. Jose, if you write for problem number A, if on your paper you wrote amount times percent times amount times percent, I'm just crossing it off, putting an F on your paper and moving on, right? Read the question. All right. Jane can do it in 4 hours. Where do I put the 4? Right here. Or right here, it really doesn't matter. Maurice can do it in 6 hours. 1/6 equals, how long does it take them together? 1 over x. All right?
Will there ever be a subtraction in between the two
No.
fractions?
Now, it couldn't be, not for us, but here's an example of when it would be a subtraction. Because keep in mind, Jane and Maurice are both doing the job together. So it's like they come in the room and they all start painting the wall or whatever they're doing. If I had a hose running into a pool, let's say, but the drain was open. Now they're both working, but they're not working together, they are working against each other. So that would be a subtraction. Whatever was going into the hose would be here, and whatever was coming out of the drain would be minus, because they're doing the opposite of each other. Does that make sense to you?
Yeah.
We're not doing that, ours will be like this, but it could be a minus in that situation. Okay, now, what do I need to do? I need to get a common denominator. What denominator, Joshua, would you like to use? 24x? You absolutely can use 24x. Now, are all of you gonna use 24x?
No.
Probably not, and that's okay. We're using 24x, because that's what he wants to do. So, that means we're gonna multiply this one by 6x, this one by 4x, and this one by 24. 6 times 4. So we end up with 6x, 1 times 6x, 6x, plus 4x equals 24. So 10x equals 24. And x equals 24 tenths, which is 12 over 5 hours. And again, there is nothing wrong with 12 over 5.
Hours.
It would be 2 2/5 hours. 2 hours and 24 minutes. But why would you go in there? Just say 12/5 hours. Okay? Putting the unit on it. Okay. Last one in this practice test. Now, Jose, what's our format?
Amount times percent
Yeah.
plus amount times percent equals amount times percent.
And we might as well write this down, because if you miss the problem, at least it looks like you know what you're doing and you might get some points. We're looking like you know what you're doing. And if you can write that down, I think you can actually fill in a whole bunch of this. What are our percents this time?
0.54,
0.54.
6.
Wait.
Oh,
What's
you
the
said
6?
percent, you said percent.
0.45.
0.45.
0.45 is my percent.
Yeah.
I'm trying not to get confused, so I'm gonna fill all those in first.
And
And this is
0.49.
0.49. Okay, so there we go. Now, there is a 6 in the problem, 6 quarts. Where does that go?
45.
Right here. And there is a how much,
X.
and this happens every time we're left with one empty parentheses. The empty parentheses is always gonna be either 6 plus x or 6 minus x, depending on where it is in the problem. Which one is it if it's the total over here?
Plus X.
Plus, that's what total means, right? Add them up. So 6 plus x. Yesterday, if I recall, our problem had a blank here. That would be 6 minus x. Okay, now we're gonna use our calculators and we're gonna do some multiplying. I better get my calculator. It's last period, Lord only knows what my brain's doing. Okay, that was all. Now, normally, I'm like yelling at you because you're too calculator dependent, but go ahead and use your calculator, because there's some very easy mistakes to make. For example, you know you have to move this 0.49x over here. And when you do that, you've got to remember that's 0.05x, 0.05. 54 minus 49 is 5. But because of where that decimal is, it's 0.05. And your calculator won't screw it up. Now I'm going to subtract this to the other side. So I get 0.24.
Yes. And you get 4.8.
And then you say that's 4.8.
Yes.
And that would be
Yeah.
Yeah. You would miss the whole problem.
yours.
If you like label wrong, would you?
It's kind of stupid. No, not the whole thing. Just do it right, and you don't have to worry about it.
Back this forward. You gotta lock in this forward.
Okay. Now, here's what I want you to do. We have one more practice test, but we also have a few extra practice problems in our notes. So I want to get those out and finish those up. Get on, let's see, it's the next to last page of your notes. It's where we left off. Down here at the bottom, it says homework practice problems. Handwritten. Homework practice.
Oh! You tried to cut my face! Yeah, but we got a big cut off this so much.
Okay, that was supposed to be done.
No, done. How should
Okay, everybody everybody is doing the homework practice problems, everybody got there? Well, I don't know, we're not gonna miss class to do it. It's been done before school. Okay, so are we good here? Yeah. Did I find it? All right. So number one is one of those big sketch things. All right, so let's see if we can get through this before the end of the period. Here we go. It's a big one. All right, so what do I do first? You factor. How does the denominator factor? That's the easy one.
I was hoping that was not the reason why you wasn't here.
How's it factor?
X plus 4.
X plus 4, X minus 4. That's the easy one. How does the top factor? X plus 3, X plus 4. Is everybody on board? So I know you notice that those cancel, and I will end up graphing this equation right here. Quigley, tell me one thing I'm gonna put in my picture. All right, where's that hole going to be?
Negative 1/8.
Because you put in -4 here and got -1, and you put in -4 here and got -8. So you are exactly right. So -4, 1/8. Okay? Now what? Let's see, we're gonna pick on here. Tyron, give me something else to put in my picture.
The denominator before, so with the x-intercept before.
No, the x-intercept comes from the numerator. So the x-intercept, yeah, so the x-intercept is going to be -3, 0. And the vertical asymptote is going to be x equals 4. Okay, so here's my problem. The top gives me my x-intercept, the bottom gives me my vertical asymptote. All right, Mary, give me something else. Perfect. And then the only thing left should be my y-intercept. And how do I find that every time? Let x be 0. So if I put a 0 in there, I get -3/4. Now, based on that, I should be able to draw my picture. So do you see an arc that's going like this? And where's the other one? Perfect. Perfect. Okay. Next one. We get this one done, I'll stop. So the more you help me, the faster it goes. Here we go. that make sense?
X minus 1, X
So x minus 1 minus 2,
Yeah.
that gives me a 3 in the middle.
X
How about the bottom?
X
Plus 5 minus 1.
Cancel out the ones.
These are gonna cancel. So y equals 2 times x minus 2 over x plus 5.
No, positive one.
Where's that hole gonna be?
Positive one.
What canceled out? So that means my hole's gonna be at 1. And 1 comma what? Well, let's put 1 in. The denominator's gonna be 6. And the numerator's gonna be, let's see, 1 minus 2 is negative 1, times 2 is negative 2, so actually 1 negative 1/3. Horizontal asymptote is gonna be y equals 2.
Vertical is going to be 2 as well.
Vertical is gonna be what?
2 as well. Oh, 5.
Vertical is gonna be x equals negative 5, because where do verticals come from?
Denominator.
Denominator.
That's for
What's my y-intercept? Put a 0 in. So the top would be negative 4, 5. So here's my y-intercept, 0, negative 4/5.
X is 2.
My x-intercept is 2 comma 0. Because where does it come from? The numerator?
Yep.
I think that's everything. All right. So these dots gotta be connected. So how does that look like? Does that look okay to everybody?
Yes.
And then where's the other piece?
Top of the corner.
Up here.
Let's go.
Right? Please do not lose that paper. We're gonna do the other 2 next time, the word problem practice. And
It is testing.
our test will be